Hi, in this video, we are going to continue our course on vectors and 3D geometry, and we'll discuss the cross product or the vector product of two vectors today. So if A and B are two vectors, we will define something called the cross product, and this is going to give us a result which is also a vector. The magnitude of the resultant cross product will be equal to mod of A mod of B sine theta, where theta is the angle between A vector and B vector. Angle between A vector and B vector. And the direction of the vector C, which is the product of these two, is going to be in the plane that is perpendicular to both A and B. So if this is the diagram for A and B, the direction of C vector is this, which is perpendicular to the plane containing A and B. So here you can say that the final vector C is perpendicular to A and C is also perpendicular to B. So vector product is basically the situation where when you multiply two given vectors, you get an output which is a vector whose length is given by AB sine theta and the direction is perpendicular to the plane containing A and B, right? Now, from this definition, we know that if A cross B becomes zero vector, that implies that either A vector is zero or B vector is zero, or A vector is parallel to B vector. If none of the two vectors are zero, then the only way in which the cross product can be zero is if the two vectors are parallel to each other, because the magnitude of this is AB sine theta, and sine theta can be zero if the angle between the two vectors is zero, right? Also, the second point that we can say from here is that if A and B are non-zero and also non-parallel, then we can conclude that the modulus of A cross B, which will be equal to mod of A mod of B sine theta's modulus, is clearly less than equal to mod of A times mod of B, right? Because sine theta will be less than equal to 1. So this inequality is true, that when you do cross product of two vectors and take their modulus, it will be less than equal to the product of the moduli of the individual vectors. So just like in the dot product, they have an inequality like this here. The next thing to note is that the cross product is not commutative. So A cross B is not equal to B cross A. In fact, A cross B will be equal to negative of B cross A. So very important idea that cross product is not commutative. I'm sure all of this is already familiar to you. I'm just writing these results because these are standard and you must know them, right? Okay, then there is a theorem about scalars. These are some standard things that you should know. Minus A cross B is equal to A cross minus B is equal to negative of A cross B. And similarly, you can write this result: L times A cross M times B is going to be LM A cross B, where L and M are scalars. So any scalars can be taken out of the cross product and you don't need to worry about them. Then the distributive law is true for vector addition. So if you have three vectors A, B, C, and if you want to do A cross B plus C, that can be written as A cross B plus A cross C. This is known as the distributive law, and it is very important to use this appropriately whenever you have three vectors in a situation like this. And remember that the order of the cross product matters. You cannot write it as A cross B plus C cross A, because C cross A will be negative of A cross C. So this distributive law, you have to be careful about the order in which you are doing the vector product, right? Okay. Then the next thing is, if you have components I, J, and K, you should know how to do the vector product across these. So you should know I cross J is K, J cross K is I, and K cross I is J. And the cross product for the same type of vectors will be 0. I cross I, J cross J will be 0. K cross K would be 0 because they are parallel. And if you reverse the order anywhere, J cross I would be minus K, and K cross J would be minus I, and I cross K would be minus J. These are easily understandable from the basic definition of your cross product and from knowing that I, J, and K are in the positive X, positive Y, and positive Z axis. A nice way to remember them is to think of them on a circle. I is here, J is here, K is here. And if you're going count in the clockwise direction, whenever you do cross product of two vectors in the clockwise direction, the answer will be the third vector. So I cross J is K, J cross K is I, and K cross I is J, right? You can see these three results here. And if you do anti-clockwise cross product, if you have to do I cross K, the answer will be minus of J. When you go anti-clockwise on the circle, the answer is negative. But when you go clockwise on the circle, then the answer is the third vector with a positive sign. So remember this circle, and that will be a good way for you to remember this result. Then using that, if you have two vectors given as a1i plus a2j plus a3k, and another vector is b1i plus b2j plus b3k, the cross product of a cross b, you can do it step by step by doing distributive multiplication of this whole expression with this, and do I cross I is 0, I cross j is k, I cross k is minus j, and so on. Or you can directly calculate it by this discriminant ijk a1, a2, a3, b1, b2, b3. So this discriminant will give you the value of this cross product, and you can see clearly this will be I cap a2 b3 minus a3 b2 minus j cap a1 b3 minus a3 b1 plus k cap a1 b2 minus a2 b1. So that will become your cross product. Remember this discriminant to calculate the cross product quickly, right? Okay. Now, another theorem that sometimes becomes useful that I can list down for you is if P vector can be written as L1 times A vector plus L2 times B vector plus L3 times C vector, and Q vector can be written as M1 times A vector plus M2 times B vector plus M3 times C vector. And basically, P and Q are being represented in terms of the three basis vectors A, B, and C. Both P and Q are being represented as a linear combination of A, B, and C. Then, if I want to calculate P cross Q, that will be equal to the discriminant B cross C, C cross A cross B, and you have L1, L2, L3, M1, M2, M3, right? So this is the same thing as the standard rule when you had IJK. Remember, if you had IJK, this was J cross K was I, K cross I was J, and J cross K was I, this was K cross I which was J, and this was I cross J which is K. So this is the same formula as if it was IJK here. But in general, if you have ABC, this is how you find the P cross Q, right? For two vectors P and Q, which are written in terms of A, B, and C, right? Okay. The next thing is an important theorem that you should be aware of. If A and B are non-zero, non-parallel vectors, then the mod of A cross B whole square will be equal to mod of A square mod of B square minus A dot B whole square. How do I get this? It is actually very simple proof. What you have to do is think of this as mod of A mod of B sine theta whole square, and that becomes mod of A square mod of B square sine square theta, which is 1 minus cos square theta. And immediately you're getting mod of A square mod of B whole square minus mod of A mod of B cos theta whole square. So this and this are basically what we have written here. Correct? So this result becomes obvious. It is a simple proof. Another thing to notice is if you want a unit vector C that is perpendicular to two given vectors A and B, then C is obviously going to be A cross B divided by mod of A cross B. Because by the definition of the cross product, A cross B is perpendicular to both A and B. So if you divide A cross B by mod of A cross B, you will get a unit vector perpendicular to the two given vectors A and B, right? So that is a standard idea that you should know. Now we come to some geometric applications of vector product. So the first thing is the area of a triangle. Area of a triangle. So if you have a triangle ABC, the area of the triangle can be written as half of AB vector cross product with AC vector. And basically it's any two consecutive sides, the vector for those sides. So A, B, C. So basically you have AB vector here and AC vector here. The cross product of these two will be the area. Similarly, you can also write it as half of CA vector and CB vector. The two vectors must originate from one particular side and go towards the two sides, and they should have an angle between them. The reason for it is obvious. You will get half of mod of AB vector mod of AC vector sine theta, where theta is the angle between these two. And obviously AC sine theta becomes like the height on this, and you have this formula becomes like a half base into height, where the base is the AB side and the height is AC sine theta, right? So this is a version of the triangle area that you can figure out. And similarly, you can also write it as BA vector cos BC vector also. So any two sides and any two vectors representing the two sides of a triangle, if you do the cross product and divide by 2, you get the area of the triangle, right? Another way to write the same area of a triangle in a slightly different way is this. So if now we are not writing the vectors for the sides, we have A, B, C are the position vectors of the vertices of a triangle ABC. In this case, the area of the triangle ABC will be simply half of A cross B plus B cross C plus C cross A. Why is that so? It is the same idea as before, but these are position vectors with respect to some origin. So this is A, B, and C. So this is my C vector, this is my A vector, this is my B vector. So obviously area of the triangle is half of AC vector cross AB vector, as we saw earlier. So half of AC vector will be C minus A and you have to do the cross of that with B minus A, right? When you multiply this, you get C cross B minus C cross A minus A cross B plus A cross A, and A cross A is 0. So you have this, and basically this is what? This is minus B cross C minus C cross A and minus A cross B. And the modulus of that will be the area. So you can take minus 1 common, the magnitude of the area will be this, right? Which is matching. So that becomes the expression for area of a triangle. Similarly, area of a parallelogram can also be represented in vector form. If you have a parallelogram like this, A, B, C, D, and the vector AB is given by A vector, and the vector BC is given by B vector, right? In that case, area of parallelogram is simply A cross B, where A vector and B vector are two consecutive sides, the vector for two consecutive sides, right? So it is also double of the area of the triangle that divides them, right? So you should know this. Similarly, if the diagonals of the parallelogram are known, for example, if in the same parallelogram we know that AC vector is given by D1 and BD vector is given by D2, then the area of the parallelogram can also be written as the cross product of the diagonals, which is half of D1 cross D2. The magnitude of this will become the area of the parallelogram. You should try to prove these two results yourself. It is not very difficult. The next thing that I want to talk about is the perpendicular distance. The perpendicular distance from point A, whose position vector is A cap, to the line through B, whose position vector is B cap, and C, whose position vector is C cap. So you have a situation like this. B is here, C is here. B cap is the position vector of this, C cap is this, and A is somewhere here. A cap is the position vector of this. I want the length of AD, the length of the perpendicular from here, right? So if I join this triangle like this, I can easily say that perpendicular AD is equal to twice of the area of the triangle by the base, right? Because half into base into height is equal to the area, right? So now twice of the area of the triangle will be half into modulus of BA vector cross BC vector divided by the base, which will be modulus of BC vector, right? Now BA vector would, okay, so this we can write simply as BA vector cross BC vector modulus divided by BC vector. And this becomes perpendicular from A to side BC, right? So we can leave this result like this. Notice the logic in which we are calculating it. We are using the area of a triangle method to find this height. And we are saying that area of the triangle can be written in terms of vectors like this, BA cross BC. And divide that by the mod of BC, you get the height of the triangle, right? So keep it like this and use it in a problem with reference to a situation when you get it, right? Okay. The next thing that I want to do is solve a few problems. There is no other theory here that I would definitely want to share right now. We'll just do a couple of problems which will help us apply what we have learned so far, right? Okay, so okay. So the first problem is this one. let A be a unit vector and B be a non-parallel vector. B be a vector not parallel to A. Not parallel to A. Okay. Find the angles. Find the angles of the triangle, the two sides of which are represented by root 3 A cross B and B minus A dot B times A. Okay. So what we have is A is a unit vector. So mod of A is 1 and B is a vector which is not parallel to A, right? So let's say that let the angle between A and B, angle between A and B be theta, right? So two sides of the triangle are being represented by these vectors. So let's say A, B, C is my triangle, and this vector AB, let's say, is root 3 times A cross B. And the vector BC is given by this, let's say, B minus A dot B A, right? So we can see that BC vector, this vector, BC vector is coplanar with A vector and B vector. And we can see that AB vector is perpendicular to A vector and B vector. How do I say this? How can I say this? Notice here that this vector is written in terms of B vector and A vector. These are constants. 1 and A dot B is a constant. So it is clearly coplanar to A and B. And this vector is in the direction of the cross product. So it is perpendicular to both A and B. So what I know right now is AB dot BC will be equal to 0 because they are 90 degree to each other, right? So that gives me clearly the angle of this side. This angle is 90. I already know this now, right? Now let's find out the modulus of AB. The modulus of AB will be root 3 mod A mod B sine theta, right? So mod A is 1, so it is root 3 B sine theta. This is the modulus of AB. What is the modulus of BC? Modulus of BC would be the mod of this vector. In order to find that, I will have to do dot product of BC with itself. So I will do that in the next page. So my BC vector is A minus, or no, B minus A dot B times A. And if I do BC mod square, that is going to be B minus A dot B times A dot product with itself, B minus A dot B times A. So this will give me mod of B square plus A dot B whole square mod of A square minus A dot B, A dot B and A dot B, A dot B. So 2 times, you will get 2 times A dot B square, right? This is after doing dot products. So this is becoming mod of B square plus A dot B will be mod of A, which is 1. So mod of B square cos square theta, this term, because mod of A is 1. And this will become minus 2 mod of A square. So mod of B square cos square theta again, right? So what I'm getting is mod of B square minus mod of B square cos square theta, which is mod of B square sine square theta, And from here I get mod of BC is equal to mod of B sine theta, right? And I already know mod of AB was equal to root 3 mod of B sine theta, right? So basically the situation is like this. We have a right angle triangle. The right angle is between AB and BC. ABC. And we know this is root 3 mod B sine theta and BC is mod B sine theta, right? So we can clearly see that the ratio of these two is 1 by root 3. So this angle should be 30 degree and this angle should be 60 degree. So by simple geometry, we are getting that this is a triangle with angles 60, 30 and 90. So notice what we did to figure out this issue. First of all, looking at the two vectors, we were able to say that one vector is coplanar with A and B and one vector is perpendicular to A and B. So the angle between the two sides there would be 90 degree. After that, it was finding the modulus of the vectors and therefore solving the question. Okay, let's look at another problem. In this question, we have if three vectors A, B, and C are such that A is not equal to 0, A cross B is equal to twice of A cross C, and mod of A is equal to mod of C is equal to 1, and mod of B is equal to 4. Angle between B and C is cos inverse of 1 by 4 and B minus 2C is equal to lambda times A. We have to find lambda. So notice that so much information is given. All we have to do is use it somehow, right? So let's think about it. First of all, from this equation, we have B minus 2C is lambda A. So, okay. We also have this relation here. So let's think of that. A cross B is equal to twice of A cross C. So we can write it as 2A cross C, or we can write it as A cross 2C, right? We saw that the scalars can be put anywhere. When you don't change the order of the vector product, the scalar can be placed anywhere. So we have A cross B is equal to A cross 2C, which means A cross B minus A cross 2C is equal to 0. Now by distributive law, this is equivalent to A cross B minus 2C is equal to 0. And since the vectors are A vector is non-zero, either you have B is equal to 2C. How can this cross product be 0? You have three options. A is 0, B minus 2C is 0, or A is parallel to B minus 2C, right? A 0 is not allowed because it is given in the question. B is not equal to 2C because if B was equal to 2C, then B and C are parallel. So angle between B and C should be 0, but the angle between B and C has been given and is not 0. This is also not allowed. So therefore we get that A is parallel to B minus 2C, which means B minus 2C therefore is coming as lambda times A. So actually we already got that here, right? We have to find this lambda. So the way to do it is to do a dot product with itself. So let's see B minus 2C dot product with B minus 2C should be equal to lambda square mod of A square, right? And remember that mod of A was given. So this is equal to lambda square. Mod of A was equal to 1. So here you're getting B mod of B square plus 4 mod of C square minus 4 times B dot C is equal to lambda square, right? And mod of B square was given as 4, so 16, plus mod of C square was given as 1, so 1 minus 4 B dot C. And this is going to be 4 times mod of B is 4, mod of C is 1, and cos of theta, the angle between B and C is 1 by 4. So this is becoming 4 into 4 into 1 by 4, and here you have a 20 minus. So this becomes 20 minus 4, so 16 is lambda square, so lambda is equal to plus or minus 4. So that is what we are getting here, right? Okay. The next problem that I want to show you is this question. In triangle ABC, A and L are points on AB and BC, such that AK is to KB is equal to 1 is to 2, and BL is to LC is also 1 is to 2. Suppose AL and CK intersect in Q if the area of triangle BQC is 1, find area of triangle ABC. So this problem uses all the stuff that we have learned so far. Let's draw a rough figure. This is the situation. This is my A, this is my B, this is my C. AK is to KB. KLN are points on AB and BC. So AK is to KB is 1 is to 2. So K will be somewhere here, and BC, L will be BL by LC. So L will be somewhere here, right? And AL and CK intersect at Q, right? This is 1 is to 2 ratio, this is 1 is to 2 ratio. This intersection it is at Q, and area of BQC is given. You have to find area of ABC, right? So best thing is to take A as the origin, and then let's say AB vector is B vector. Basically position vector of B is B, and let's say position vector of C is C. So obviously now L vector by section formula will be 1 times C plus 2 times B by 3, right? So it will be C plus 2B by 3, and K vector by again section formula will be 2 times 0 plus 1 times B by 3. So it will be B by 3, right? Now I need to find the point Q, right? So equation of line AL. Line AL passing through 2 points would be R is equal to 1 minus T into 0 plus T times L, right? So it will be T times 2B plus C by 3. That is my AL line. And similarly, CK line will be passing through C and K. So can be written as R is equal to 1 minus S C plus S times K is C by 3. K is B by 3, right? So this is my CK line, right? So line CK and AL intersect at Q. So if I intersect these two lines, I should get the coordinates of Q, right? So let's do that intersection on the next page. One line was T 2B plus C by 3. And one line was 1 minus SC plus S into B by 3, right? So from here you're getting 2T by 3 B cap plus T by 3 C cap here is R. And here you're getting 1 minus S C cap plus S by 3 B cap. So clearly, if the lines intersect at a point, you should have S by 3 is 2T by 3. S is equal to 2T. And the other case is T by 3 is equal to 1 minus S. So this is 1 minus 2t is t by 3. So you have 2t plus t by 3 is 7t by 3 is equal to 1. So t is equal to 3 by 7. And if t is 3 by 7, s is what? 6 by 7. Right? And the point is r is equal to 3 by 7 into 2b plus c by 3. So the point is basically 2b plus c by 7. That point becomes your cube, right? I've solved the line and I found the point of point Q. Now we will use the fact that area of BQC, area of triangle BQC is equal to 1. And that should be half of the mod of BQ cross BC, right? Okay, so I will do this. So that will be half of BQ will be 2b plus c by 7 minus b, and cross product with BC would be c minus b. So this is coming out to be c minus 5b by 7 cross product with c minus b. That is my half, that is 1, the area. So evaluating this cross product, 1 by 7 comes out, 1 by 14 is here, and we have modulus c cross c is 0, minus c cross b, minus 5b cross c, and that's it, because the other part is 0, right? So this is basically b cross c minus 5 times b cross c. So it is 4 times b cross c. So 4 by 14 mod of b cross c is equal to 1. So mod of b cross c is coming out to be 7 by 2, right? And if you look at the area of the triangle ABC, this vector is B and this vector is C. So area of the triangle should be half of mod of B cross C, right? And if that is the area of the triangle, answer of our question would be 7 by 4. That becomes your area of the required triangle. So notice that we have used everything that we have learned so far in vectors. We use section formula, we use the equation of a straight line. We solve two equations of straight lines to find point Q. Then we use the area formulas that we learned today by vector product to get a relationship on B cross C, and from there we found our answer. So that concludes our discussion today. We have finished our vector product. And in the next class, we'll look at triple products, scalar triple product and vector triple products, right? So stay tuned for the next video. If you like the content, please subscribe to the channel and like the video. I will get back to you next time with more content on triple product of vectors. That's it for now. I'll see you next time.